Okay, part 3. So basically, Alan, Bart, and Cora and Dane have 2 numbers each. So that's 8 numbers, but there are 9 numbers, 1 to 9. Oh, so this one is just guess and check. You can start here, right? My numbers add up to 6, so you can guess all the possible numbers, right? Which are 1, 5, 2, 4, 3, 3, something like that. Oh, it can't be 3, 3. So 1, 5, and 2, 4. Or you could start from this one. Cora says the product of my numbers is 18, so you don't really have many options. That's just 2, 9, and 3, 6. You can't have 1 and 18 because they're only 1-digit numbers. So I think those two are a good starting point. You can't really, it's not really wise to start with Bart's clue. The difference between my numbers is 5 because there's like a lot. 1, 6, 2, 7. Actually, there aren't a lot either. So honestly, I guess you can just start from anywhere. Okay, so let's just start with Alan's then. My numbers add up to 6, so maybe 1 and 5. Let's try that. Okay, let's put a name. A, B, C, D. Okay, Alan's is 1 and 5. Let's just do guess and check. 1 and 5. Bart says the difference of my numbers is 5. So maybe we could have a 2, 7. Yeah. Product is 18. That's maybe 3 and 6. And Dane said one of my numbers is twice the other one. So possibly, okay, we don't really have that much choices left. Only 4 and 8. Yeah, so this is one way to do it. 1, 2, 3, 4, 5, 6, 7, 8. The question is asking for the missing one, the number left on the table. So the only number that's not here is going to be 9. So that should be E. Okay, let's check if it is indeed E. 18 E. Yeah, it is. Yeah, so this one is just guess and check. Number 19. There are exactly 2 frogs in each row and each column is shown below. Yep. 2 over here. In this row, 2 in this row, 2 in this row. When you count the columns, there's 2 in each column as well. Okay, so the frogs decide that 2 of them will jump to a neighboring empty cell at the same time. Yeah, so any of these 2 frogs will jump to a neighboring cell. Neighboring cell basically just means like from here to here. Like you can't jump, like if you're this frog, you can't jump over here. That's not a neighboring cell. You can just jump to a cell beside you. So like for this one, you can do here and this one. Okay. So yeah, 2 of them will jump to a neighboring cell. So it could be this one and this one, or maybe this one and this one, for example. Let's see. Okay, after 2 frogs jump, there are still exactly 2 frogs in each row and each column. So they maintain the 2 in each row and 2 in each column thingy. Okay, how many ways can the frogs do this? Okay, let's try to analyze the question. Let's say this frog jumps here and this frog jumps here. Right? You can't really do that, right? Because they wouldn't be here anymore, but they would be here and here. We can't do that because this row would have 3 frogs and this row would have 3 frogs. So basically, to maintain the system, for example, if this frog decides to jump over here, this one would have 3 frogs now, right? So we can't do that. So one of them has to move somewhere else. So like this one is kind of stuck, can't really move anywhere because this one would be, this part is taken up and this part is also taken up. So if this frog really wants to jump here, then this frog has to jump over here. So that way, this row still has 2 frogs and this row still has 2 frogs. Yeah, so that's one way to do it, right? You basically have to kind of exchange. This row loses a frog when this frog goes here, and this row will have 3 now, so this frog will have to move here. Yeah. After that, there are still 2 frogs in each row and each column. So, but that's only one way to do it. Another way to do it, let's see. Okay, we've investigated this frog. Maybe we can try this frog. I mean, this frog can move here, but then this column will have 3 frogs, so this frog will have to move here. Yep. And that means this row will have 2 frogs over here and over here. And this row will have 2 frogs, this one and this one. So that's another way to do it. So we've looked at these frogs, this, and this. Okay, let's see if there are more ways. We haven't really looked at these 2 frogs, right? Because we've looked at this frog. If this frog goes here, this frog has to go here. And if this frog has to go here, this frog has to go here. Yep, so that's nearly everyone investigated, and this one really can't go anywhere. Because if it does move here, oh wait, we have investigated it. Never mind. So we're left with these 2 frogs, and well, obviously it's quite easy to see that if this frog goes here, for example, then this frog has to go here to maintain the 2 frogs in every column thing. But that's not it, right? That's another way. So 3 ways so far. But this frog, I mean, this isn't his only option. He can actually go up as well. So if he goes up, this frog has to go down. Yep, so that's 4 ways in total. 19D. Yep, it is D. Yeah, so you just have to count. Like, if this frog has to go here, for example, this frog has to go here. If this frog goes here, this frog has to go here. So it's just like, one has to counteract the other. If one goes up, one goes down. If one goes left, one goes right. Something like that. If this one goes here, this one goes here. And lastly, if this one goes here, this one has to go here. So that's 4 in total. Okay, there are 2 types of toy blocks, the white one and the red one. So to make a cube, which is like this cube right over here, this is a cube, you can either have 1 white block and 1 red block. So we put this on top of this to make a cube, or you can have 4 white blocks, something that looks like this over here. See, this whole cube, this small cube, is made up of 4 white pieces. So either you have a white and red, or 4 white. But it's impossible to just make a small cube using just the red piece, right? Yeah, because this wouldn't be a cube. You need a white one to go on top of it, like that. Okay, so every time you see a red one, that means there's a white one. There's a white piece hidden. Like this one, for example, there's a white piece hidden there somewhere, because you can't make a small cube without the white piece. If you can't just make it using a red piece. All right. What is the smallest number of white blocks needed to make the large cube? All right, so this large cube is made up of 8 small cubes, right? 1, 2, 3, 4, 5, 6, 7, and then there's one in the back, 8. Yep, so don't get tricked there. It has to have 8 smaller cubes. Okay, let's take a look at it one by one. Let's start here. There's a red piece. That means there has to be one white piece hidden, because you can't make a small cube only using the red piece. Next one, that's 4 white pieces. Can't really change that. 4. Over here, that's another white piece, right? Because you can't make a small cube using only a red piece. This one at the bottom is kind of easy. There's obviously only one white piece. And over here, this one obviously has 4 red pieces. So that's 4. This one's slightly in the back. It could have 4 white pieces, but it could also just be 1 white and 1 red, where we just can't see the red parts. So let's just say we want the minimum number of white blocks. So let's just say that's 1 white block. And then for like this cube, right, that we're talking about, the small cube, it could be like there's a red piece hidden somewhere, but we can only see this face. So yeah, it's possible it could be hidden. Same for this one on top. It could be a white piece that we're looking at. And then we only want the minimum number of white blocks. So there's a red piece probably under it. Yeah. So that's another one. And then obviously we only counted 7 small cubes. There is one hidden on the lower half and on the back side that we can't really see. And if we want the minimum number of white blocks, just basically 1. Because it could also be like a small block made up of 4 white pieces, but we don't really want that, right? We want the 1 red and 1 white. So let's just say 1. Okay, 1 plus 4 plus 1 plus 1 plus 4 plus 1. How many are there in total over here? 1, 4, 5, 6, 7, 11, 12, 13, and 14. D. Let's check if it's D. It is indeed D. Okay.